folks. I'm going to run through sum and difference identities for our Unit 6, and we're just going to keep it fairly basic. I'll have more examples in the hard copy notes that I'll post on Canvas, but definitely refer to those. So we're just going to focus on these identities right here, and we got 6 of them. And they're just variations on a theme, because what we're going to have is sine of two angles that are added together. Basically, it's alpha and beta is sine of alpha cosine of beta plus cosine of alpha plus sine of beta. And then you have, when you subtract, a variation on the theme. If you notice, these are pretty much the same, but we have the minus right here. So when we're adding, we have the plus here. When we're subtracting, we have the minus here. Cosine, a little bit different. So when we're adding our two angles, we're actually going to subtract, but you notice that you have two cosines here and two sines here. And then you have cosine subtracting. You're going to add the two cosine operations and the two sine operations. Tangent is something that would be an interesting proof that we would do in the classroom. And when we did identities the previous week, we can convert this identity into here, and we can actually play around with sine and cosine on these as well. It's actually a pretty fascinating thing that we normally would have done in the classroom. But again, we're cutting out a whole bunch of stuff. So one way to do these is learn by practicing. And in college, I asked a couple people, including one of my daughter. She said she had to have these memorized, but another student at a different college said that they were given formula charts, basically similar to the cheat sheet that I gave y'all. So it just really depends on the school that you go to, whether you have to have these memorized or not. It's always a good idea to, and they're not hard to memorize. It takes actually just a few minutes after you've gone through some homework. So here is our first example, cosine of 120 plus 45. And we're going to do an exercise here, because if you look at example 1 and example 2, this has parentheses and this really doesn't. And we're thinking, well, what's the difference? This is going to show you the difference of why we have to use this identity right here. So we're going to call this alpha, and we'll call this beta. Okay, and let's just go ahead and do cosine of 120 times cosine of 45 plus sine of 120 sine of 45. You look on your unit circle, and you're going to find that this is going to be negative 1/2. Cosine of 45 is root 2 over 2. And then sine of 120 is root 3 over 2. This is all straight off your unit circle. And again, in class, you had been doing this without, by memory. You would have that unit circle memorized. So that's probably an expectation in college as well. Alrighty, so we're just going to simply multiply straight across. So that's negative root 2 over 4. That's negative root 6 over 4. And these are common denominators, so we have just negative root 2 plus root 6 all over 4. Okay. So let's take a look at the unit circle and figure out what cosine of 120 is. That's negative 1/2. We already did that up above. And cosine of 45 is root 2 over 2. And that's simply just negative 1 plus root 2 over 2. As you can see, these are completely different. So you just can't simply do, some people will probably say, well, why can't we distribute the cosine? It's a function. This is an input to a function. There's no type of distribution like that. Alrighty, so moving on. So 3, sine 135 to third minus 30. Well, here, if you look on your cheat sheet, this is going to be your formula. And this is going to be your alpha, and this is going to be your beta. All right, you're just going to plug them in. So let's go ahead and do that. That's going to be sine 135 times cosine 30. And we're going to subtract, all right, cosine 135. It's sort of like switch places here. And again, after you've done a whole bunch of homework. Now, typically, in a lot of schools, you open up the textbook and they assign you problems 1 through 45 or something like that. So you get a lot of repetitive practice. I encourage y'all to do that, especially those going to a 4-year university next year. Alrighty, so this is going to be root 2 over 2 times root 3 over 2. And then you're going to subtract. Now cosine of 135 is a negative root 2 over 2, so I'll put that in parentheses real quick. And then we got 1/2 for sine of 30. So let's clean it up. That multiplies straight across. That's going to be root 6 over 4. And a negative times a negative is a positive, so root 2 over 4. So that's just root 6 plus root 2 over 4. And let's just go ahead and do this one real quick just to prove that you can't break this apart. That's a big no-no. It's a very common mistake. So again, on the unit circle, that's just root 2 over 2. And that's minus 1/2. Common denominator, so that's root 2 minus 1 over 2. That's all. Okay, let's take a look at this one. This is where we're heading. So there's multiple ways to do this. You can find a sum or a difference as long as the numbers add up to 105 or subtract down to 105. You're good to go. And you want to break it up into unit circle numbers. That's not always possible, but that's for later courses. So 60 plus 45. I think that's the easiest way to go about it. Okay? This is my alpha, this is my beta. So I'm going to do cosine of 60 times cosine of 45. We're going to subtract sine of 60 times sine of 45. Unit circle tells me that this is 1/2 times root 2 over 2. And this is root 3 over 2. Yeah, it is. I had to think for a second. And times root 2 over 2. Okay, multiplying straight across gives us root 2 over 4 and root 6 over 4. You're going to get a lot of these because we're keeping it very simple. Variations that it's going to look the same, but there'll be a subtle difference. All right? So that was that one. So now let's move on and let's take a look at sine of 165. Again, I need to add or subtract to make it usable on the unit circle. And I'm thinking 135 and 30. Okay. So I'm going to apply my sum angle, and that's going to be sine 135, because this is your alpha and this is your beta, times cosine of 30. They take turns. And then it's cosine's turn of 135, and then the sine of 30. Unit circle tells me that that's root 2 over 2. And this is root 3 over 2. Cosine of, hey, my cat's trying to sneak in. Root 2 over 2, 135 is that, and sine of 1/2. Okay? Multiply straight across, that's root 6 over 4. Minus root 2 over 4. So that's just root 6 minus root 2 over 4. Yippee-yay. Let's do a tan. Tans can get very, very complex very fast because of the complex fractions. The trig's not difficult. It's the fractions that get a lot of students. And you want to show up to your freshman college math class pretty darn proficient at fractions. They're not going to take a dim view of someone who can't do 6th grade math. So let's get on with that. Okay? So I can break this up into a plus or minus. It doesn't matter. I could do tan of 150 plus 45. Or I can think, okay, what's 225 minus 30? I could do either one. I'll just go ahead and do this one. So I'm going to treat this as tan 150 plus 45. All right? So that's this puppy right here. So I'm going to carefully write it all out. Tan 150 plus tan 45 all over 1 minus tan 150 tan 45 Okay, and I'm going to go ahead and look at my unit circle and figure out what all these again are. And you need to go back and, remember sine over cosine is tan. Okay. So you got to think of what those were. Now, tan 150 is your root 3 over 3 scenario. So it's going to be negative because you're in the second quadrant. So negative root 3 over 3. Tan of 45 is just 1. Okay. So 1, that's just a 1, minus tan of 150 again. So that's root 3 over 3. But it's a negative, so I'm going to put that in parentheses. And I'm multiplying by 1. So I was fortunate to have some 1s in here. So it worked out kind of nice using this scenario. Okay, might have been a little bit more difficult with this one up here. So I'm going to clean it up. I'm going to find common denominators here. This is nothing more than just 3 over 3. All right, that's just no, here I'll just write it. Because I know some of you all don't like fractions. So that's just 3 over 3. Over a big fraction of 3 over 3. Negative times negative is a positive of root 3 over 3. Let's put these all under one fraction here. So that's just going to be negative root 3 plus 3 over 3. Okay. Doing a little bit more work than I normally would. And that's going to be 3 plus root 3 over 3. Flip and multiply. Okay. I'll go ahead and write it out. Root 3 plus 3 over 3 times 3 over 3 plus root 3. That's a negative, I'm sorry. There we go. And 3 plus root 3. Well, the 3's cancel out. All right. So the 3's cancel out here and here. So you have negative root 3 plus 3 over 3 plus root 3. And if I wanted to, I could multiply by conjugates and get that out. But I'll let you stop right here. That's perfectly fine for now. Okay? But yeah, in another class and in the future, you'd probably get that radical out of the denominator by multiplying by the conjugate. Okay, so let's take a look at one more. Cosine of 5 pi over 12. Radians are going to be incredibly popular. For those taking calculus next year, you're going to deal a lot with radians. But there's an easy way to do this. You could convert this 5 pi over 12 into degrees, all right, by multiplying by 180 over pi. Pi's cancel out. 12 into 180 times 5 gives me 75. All right, that's 75 degrees. So I can write this as cosine of 75 degrees, okay? And that's just basically 45 plus 30. Okay, now cosine of 45 is just the same thing as pi over 4. And that's going to be pi over 6. All right, something like that. Okay, so you just use your formula. All right, and just for the fun of it, because I've already done degrees, I'm going to keep it in radians. So I'm going to do cosine of pi over 4 times cosine of pi over 6. I could have easily put this in degrees instead, 45 and 30. It's going to come out to be the same because you're just going to go off your unit circle. Now it's the sine's turn. Sine pi over 4 times sine pi over 6. I got a reminder. I wonder if I'm supposed to be somewhere. I wonder if there's a meeting starting. Alrighty, so this is root 2 over 2, right off the unit circle, times root 3 over 2, minus root 2 over 2, times 1/2. So that's going to be root 6 over 4, minus root 2 over 4, which we could put all into one fraction, root 6 minus root 2 all over 4. Alrighty. Okay, so that is it. I am going to do part 2 next, but I gotta go see what all this stuff is. We're skipping this. We'll do part 2 in a few moments. All right, bye.